Hello my dears, how are you all? So what we studied in the last class? We studied about the second order system in very detail, and also we derived the transfer function, right? Transfer function of the second order system, and we got the standard equation of the solution, right? Solution that we obtained in a second order system. And now there is a relationship between that. Actually yesterday itself I have to tell you that but I forgot that. Suppose here is a pole, my dear. Suppose here is a pole. Pole in the sense it having some, we have the relation, right? S is equal to, what was that relation? S is equal to, what was the relation? Minus theta omega n plus or minus omega j omega d. Am I right? Minus theta omega n plus or minus j omega d. Correct? This was our equation, na? Minus theta solution, right? Solution of the S. So S is equal to zeta omega n, not minus omega. Simply zeta omega n plus or minus j into omega d. Yes, it is minus actually, right? For minus theta omega n plus or minus j omega d, where omega d is nothing but what? Omega d is nothing but omega n root of 1 minus theta square. Yesterday we obtained this equation, right? Then what will be this angle theta? Which means this is nothing but, my dear, both real and imaginary part. Let us take minus theta omega n plus j omega t. Just you take one value of s. Okay, let be s1. So what will be this? Minus theta omega n will be here, right? So this point will be minus theta omega n. And what is this point? It will be j into omega d. Correct? J into omega d, because it's a j axis, right? Sigma plus j omega axis now. So it will be omega d. Simply omega d you can take because already j is there now. Simply omega d and what sigma is there. That is the imaginary plus real part. Correct? If you take the cos theta, my dear, if you take the cos theta, what will be cos theta? Cos theta will be nothing but adjacent side divided by hypotenuse, correct? So adjacent side is minus theta omega divided by hypotenuse is nothing but this one. This one will be obtained by adding this plus this, correct? So root of minus theta omega n the whole square plus omega d square. Am I correct, my dears? Am I correct? Hypotenuse is nothing but cos theta is equal to adjacent side by hypotenuse. Adjacent side is minus theta omega divided by hypotenuse means what? This plus this. This is nothing but minus theta omega and this is nothing but omega. If you simplify and solve this, you will get one thing, my dear. Because omega d is equal to omega n root of 1 minus theta square. We will do. Can we do that? Okay. Minus theta omega n whole divided by root of square means it is theta square omega n square plus omega d is nothing but, my dear, omega n root of 1 minus theta square. So omega n into 1 minus theta square. So it will become minus theta omega n whole divided by, what was that? Root of theta square omega n square plus omega n square minus theta square omega n square. So this and this get cancelled. Simply minus theta omega n whole divided by simply you take the magnitude, my dear. Simply you take the magnitude. Okay, simply you take the magnitude, because cos theta is just an angle, na? So you take the magnitude. Okay, for simplicity of derivation. So theta omega n divided by simply it will contain only omega n, correct? So omega n get cancelled. So finally you will obtain a very important relationship in this time domain analysis or the second order system, which is nothing but cos theta equal to zeta. It is very important relation. Very important relation. Very important relation, my dear. Cos theta equal to zeta, where theta is the damping ratio. You know this? Already know that, damping ratio. And theta is nothing but the angle by which the pole lies. Correct, na? The angle by which the pole, because S representing the pole, my dear. S representing the pole, right? So it representing, because it deals with the, why it is called the pole? Because the denominator of the transfer function is 1 divided by s square plus 2 theta, right? Meaning we have the transfer function now, omega n square. You should remember all the time this. Okay, s square plus 2 theta omega ns plus omega n square. Equating this denominator equal to 0, it is called the characteristics equation. From the characteristics equation, we obtained the value of s, my dear. So the characteristic equation equal denominator equal to 0 will always give you the value of pole. Equating the numerator equal to 0 will always give you the value of 0. So it is representing the pole. That is why here it is pole, not 0. Not 0. So the angle by which the pole is subtended, the pole subtended with the x-axis is called, this is called the theta. This is called the theta. Is it clear? And listen, my dear, why this pole is left side means, I will tell you one easy trick to find the stability of the system. If the system is stable, then definitely all the poles will lies left side of the S plane. This is called the S plane. The whole S is equal to sigma plus j omega. Okay. If every pole lies on the left side, it is called the stable system. If any pole lies on the right side, the system will unstable. If all the pole lies on the axis, the imaginary axis, then the system is said to be marginally stable. That we will learn later. For now, just you learn this. If we are dealing with a stable system, right? Second order is a stable system. We are not dealing with an unstable system. We are dealing with a stable system. Of course, this is a stable system. So that's all about. So the cos theta is equal to zeta. You always remember cos theta is equal to zeta. You always remember. That's very, very important relation, my dear. That's very, very important relationship. Okay. Is it clear? Cos theta equal to zeta is very, very important. Next, you have to see impulse response of second order system. This is all in your syllabus, my dears. It's all in your syllabus. Impulse response of a second order system, my dear. Okay, listen. So we have the transfer function T of s equal to what? Omega n square whole divided by s square plus 2t is omega ns plus omega n square. Correct? Am I correct, my dears? This is general format, right? This is the general format. Where omega n is equal to 1 by LC, na? You remember that term, na? This 2 theta omega n is equal to r by L, na? So you remember all this, right? That is nothing but, my dear, y of s divided by x of s is equal to this omega n square whole divided by s square plus 2 theta omega n into s plus omega n square. Am I correct? Suppose let x of t will be equal to impulse, that is nothing but del of t, or x of s will become what? 1. The impulse response, I mean the Laplace transform of the impulse will be equal to 1. We already learned this. So substitute this value, y of s will become what, my dear? 1 into, because x of s goes there, omega n square divided by s square plus 2 theta omega ns plus omega n square. And if you want to find this y of t, my dear, you have to take the L inverse of y of s. For that, you need what? You need to factorize partial fraction method. That is nothing but, my dear, a divided by, no need to partial, right? No need to, I mean, it is directly what? S plus, you should write in the form of s plus a and b divided by s plus b. You should write this equation in the form of these, and you find the value of a and b, and later we have to take the inverse Laplace transform, because the derivation that is not our area of interest, because we already learned for one. That is just for your clearing, doubt clearing, okay, how it is arrived. So similarly you can take the factorization of this, and you will find the inverse Laplace transform here, and that y of t only we have to remain, my dear. That y of t is equal to omega n divided by root of 1 minus eta square into e raised to minus eta omega n t into sine of omega d t omega dt u of t. So this will be the y of t value, y of n divided by 1 minus eta square and e raised to minus eta omega n t sine of omega dt t omega dt into u of t. So this equation only you have to remember this equation, because this derivation part how that equation, that is not not our area of interest in the sense of what the competition examination point of view. If you are preparing for a university examination, then derivation will be asked, right? But for competitive examination it will not be asked definitely. So this y of t only you have to remember what will be the structure of y of t. Omega n divided by root of 1 minus eta square e raised to minus eta omega n divided by sine omega dt plus into u of t. So from this you can notice one thing, my dear. The output contains an exponentially decaying sinusoidal term. Reason? It is very, very important. The output contains the exponentially decaying. E raised to minus means it is decaying exponentially, not rising exponentially, my dear. Not rising exponentially, but exponentially decaying. E raised to minus means exponentially decaying, okay, sinusoidal what? Function. That means the output will be in the form of y of t will be for this input, my dear, for this input, that is the for unit impulse input, the output will be in the form of, this will be the output. This is the y of t. That is sinusoidal function is there because it contains sine omega dt, but in the presence of e raised to minus eta omega n is exponentially decaying curve. This is decaying. The sinusoidal will be slowly decaying function. So that is the output of the equation. That is the output equation. That waveform will be the nature of output. That waveform will be the nature of output, my dears. Okay? Is it clear? Is it clear? And let us check the stability of the system. Stability. Stability. We know this. This is a stable system. Of course we know, but we have to check. How can we step from stability from y of t? Check for absolutely integrable, right? Absolutely integrability. We already learned this, right? Which is nothing but, my dear, y of t at t tends to infinity will be what? Y of t at t tends to infinity will be what, my dear? E raised to minus infinity will be what? 0. So definitely this is a stable system. So this is a stable system. So I will tell you one trick to find stable system. In time domain, just substitute t is equal to infinity. If it give you 0, then this system is stable. If it gives 0, the system is stable, my dear. And for S domain analysis, or in S domain, check whether any pole lies lies on the right side of the imaginary axis. If it is so, then the system will be unstable. Is it clear? For stability, y of t tends to infinity, check that. If it is get 0 means it's a stable system. For S plane, S domain analysis, if it is in Laplace transform, you simply check the poles. Poles, how can we check? Check, take the denominator, that's all. Take the denominator and equate to 0, you will get the pole. So if any pole lies on the right half of the S plane, which is nothing but this is the imaginary axis, my dear, and right side of the imaginary axis, my right side, your right side, my right side. If it right on the right side of the imaginary axis, the system will be unstable. So in these two ways you can use for checking the stability of the system, ideas. These two ways you can use it for finding the stability of the system. Is it clear? So now you got the impulse response of the second order system. Okay, impulse response of a second order system. Impulse response of a second order system. So only this output equation y of t, that only you have to remember. That only you have to remember. Okay. That only you have to remember, my dears. Write a question. Write a question. I mean, the question itself you will get a lot of later. Impulse response of second order system is given by 10 e raised to minus 2t sine 0.6 t into u of t. Okay, find omega d comma theta omega n atom. How can we find that? If you have an equation like this, my dear, you have to compare it with the output equation. Our output equation, again you have to write the output equation. What was our output equation? We have y of t will be equal to what, my dear? Omega n divided by root of 1 minus theta square into e raised to minus theta omega n t into sine of omega d t plus, sorry, not plus, it is into e of t. This is the output equation. So compare this equation with that equation. You will get, my dears, you will get one thing. E raised to minus theta omega n. So minus theta omega n will be equal to what? Minus 2. Correct? So simply theta into omega n will be equal to 2. And sine of omega d 0.6 na. So omega d is equal to what? 0.6. So omega d is nothing but, my dear, omega d is nothing but what? Omega n root of 1 minus theta square equal to what? 0.6. Okay. So you got what? Omega d, and you got theta. How can we find the theta then? How can we find the theta then? Theta omega n is equal to minus 2. Yes. Yes. So that 10 value na. Okay. How can we find theta? How can we find theta? Okay, we have what, that is 10 is equal to omega n divided by root of 1 minus theta square. Very good. Squaring on both sides, 100 will give you omega n square divided by 1 minus theta square, my dear. So 100 minus, is there any terms for 1 minus theta square? Yes, 1 minus theta square is nothing but, no need to squaring and all, right? No need to squaring and all. No need to squaring and all, my dear. Simply you can substitute. So 10 will be equal to omega n divided by, what is 1 minus theta square? It is nothing but 0.6 by omega n. Correct na? 0.6 by omega n. Correct? So you will get, correct here, 1 by theta, what is 1 minus theta square? 0.6 divided by omega n. So instead of this, I can substitute 0.6 by omega n. Omega n goes outside. So omega n square will be equal to 0.6. Correct? 10 into 0.6 means, it is simply 10 into 0.6 means simply 6. Correct na? So omega n will be equal to root 6. Omega n square will be equal to 10 into 0.6 means 6. So omega n will be root 6. So you got the value of omega n. Next, theta. Theta omega n is equal to 2, my dear. So theta will be 2 divided by root 6. So of course it will be less than 1 na. Less than 1, this value will be less than 1 na. So it is an underdamped system. It's an underdamped system. So you got theta, I mean theta also. Omega d is nothing but omega n root of 1 minus theta square. So which is nothing but my here. Yeah, it's a definitely it is directly given now. It is directly given now 0.6. It is already given now 0.6. So you got all the values. Theta you got. See, how can we compare and finding the answer? How can we comparing and finding the answer? It's very, very important. For examination point of view, it's very, very important, because a standard signal will be given to you and you have to find the parameters zeta, omega d, omega n, etc. Is it clear? Is there any doubt? Is there any doubt, my dears? Is there any doubt? Can I have this? Learn the concept, feel the concept and study. Okay? Next you have to see step response. Next, initially we got the impulse response. Now step response of second order system. Okay, so y of s by x of s is again we have omega n square whole divided by bar you write this, huh? Repeatedly you write this, you will definitely by heart this. So y of s will be equal to x of s is nothing but for second order system what will be x of s, my dear? X of t, what will be the step response means? It is simply x of t will be, suppose unit step I mean u of t. Then x of s will be equal to what? 1 by s. So over y of s will be equal to 1 by s into omega n square whole divided by s square plus 2 zeta omega n s plus omega n square. Am I correct, my dear? Am I correct? So both the numerator and denominator contains some function of s, right? So it can be factorized. It can be simplified in the form of a by s. S will be come here, right? This s will be come here now, a by s plus this is a second order equation now. So factorize, I mean partial fraction will be bs plus c divided by s square plus 2 zeta omega ns plus omega n square. Am I correct? And if you factorize this and substitute the value of a and b, okay, it's a very big process, my dear. It will contain up to 1 or 2 pages. It will contain only derivation. So we don't want that derivation. Okay, we just want the output. This is the output equation. This is the output equation, my dear. Only this you have to remember. 1 minus e raised to minus theta omega n t divided by 1 minus theta square sin omega dt plus theta plus it. And what is the difference here, my dear? What is the difference here? There is a term which is exponentially decaying term is also there, but there is a phase difference. If you applying a step signal, it makes a phase difference. But in the case of a impulse response now, it didn't make any phase difference because that term contained only sin omega d t. There is no theta factor, right? But now there is a theta factor, which implies that the step response always makes some phase difference. Step response always makes some phase difference. And write like step response introduce a phase difference. So that you can conclude from that. Okay, so only this is term. So what is the error now? What is the error? Why I didn't take error for that impulse? Because impulse na del of t is, you can't compare that with the output equation, right? Now that too exists for very long duration of time. But step input means step input, ramp input, parabolic input, etc., etc. It will exist for very long duration of time. So error will be more when that signal is applied. But impulse is very short duration signal, so error can be what? negligible. You can't take the error. You can't consider for error because it exists for very long duration, very short duration of time. But u of t, ramp signal, parabolic signal, all signal will be exist for very long duration. So always there will be an error associated with these signals, my dears. Okay, so it is nothing but e of t will be equal to error signal. E of t will be equal to again input minus output. So input is minus nothing but u of t, minus output is nothing but u of t into 1 minus e raised to minus eta omega nt whole divided out of 1 minus eta square into sine of omega dt plus theta. Okay, so these will be the what? U of t. So u of t and this u of t get cancelled. So simply you will get e raised to minus eta omega nt divided by root of 1 minus eta square into sine of omega dt plus theta, my dears. So this is nothing but the error e of t. And what will be the steady state error? ESS, which is nothing but, how can we find the that is steady state error? That is nothing but the what? What? Y of t at a t tends to infinity. So it will become simply what? E raised to minus infinity. Oh, this will be the error. E raised to minus infinity will be 0. Steady state error will be equal to what, my dear? 0. And this is a stable system because it's absolutely integrable also, like impulse response. And now it is a stable system because it is absolutely integrable. Absolutely integrable, I guess. It's absolutely integrable. Is it clear, my dears? Is it clear? Is it clear? And I'll tell you one general thing, my dear. The success of any competitive examination, I mean, the person who is attending the competitive examination, how he is in success means, or how he got success, it lies in its revision. Revision. It's very, very important term, my dear. Very, very important. So why we have to remember all this factor or this equation? See, suppose you are looking for one time, it won't be in your mind. Even though 2 or 3 times it won't be in your mind, but 4, 5, 6, until you become a master, you have to continuously revise. You have to continuously revision is the best thing for what? That is the only trick to. What is the trick actually? It is not the trick actually. That is the only way for attaining success. Okay. If you ask for any successful person, I mean in competitive examination point of view, the main thing they will tell you, I got revised by 10 times, 15 times or more than that sometime, and practice. Only these 2 things will let you to success. Okay, so remember, revision. Weekly once you have to revise all the subjects in the sense whatever you covered during that week, you have to revise it continuously. Otherwise it will not be in your mind. Yes, because these terms are very, very high level term. I mean high level what derivations and high level what process are there in control system. Do you think it is that much easy? Learning this is that much easy? Do you think? No, it's difficult actually. But we are trying to move in a easier manner as much as possible. But revision, unless you revise these, it won't be in your mind. It won't be in your mind. So please revise continuously. Please revise continuously. Okay. Please revise continuously. Next, time domain specifications. See, my dear, we got the output. This will be the output, my dear. This will be the output of the what? A response of a second order system under step input. This is the step input. Okay, time domain specification means delay time, rise time, peak overshoot, everything you are to remember now. We are going to derive now, or we are going to learn now. Okay, so before that, y of t will be this form. How this one arrived? In your university, in your classroom also, you may got this one, right? During the class time also, you got one, right? When I was a student, I got this one and I really mug up. I got really mug up and go to examination. But later on, I understand why this one will obtain. It is that much simple, my dear. What is that? Just see the output equation. Y of t will be equal to 1 minus e raised to minus eta omega nt divided by 1 minus eta square into sine of omega dt plus theta. Correct now? At t is equal to infinity, this will long for very long time, my dear. At t is equal to infinity, this term whole will become 0. So only y of t will become 1. This is simple. Only y of t will become 1. That is why for infinity we obtain 1. That is a stable output of the system. Stable output will be always 1 because we applied a unit step signal. So the output will be 1. Okay, and we are going to see some important specifications, my dear. First one, delay time. It is represented by TD. So delay time means it is a time taken by the system. The time taken by the system to attain. Not here. This is TD. This is TD. If I write this, it will be more and more complicated. Simply I marked here. Okay. I will write here. TD. It is the time taken by the output by the system to attain 50% of the final value. It is the time taken by the system to attain 50% of the final value. 50 means, my dear, this will be 0.5. This will be 0.5. Is it clear? This will be 0.5. So that is magnitude will be 0.5. So what time it will take for attaining that TD, delay time is equal to TD will be equal to, there is a relation 1 plus 0.7 theta divided by omega. Just remember this equation, my dear. For problem solving only these are very useful. So you just remember this, that's all. So that is the concept of delay time. Okay. Next. 1 plus 0.7 theta divided by omega n. Where omega n is, this natural frequency, and omega, theta is damping ratio, right? And next is rise time. It is represented by TR. Rise time is very, very important, my dear. And first we can write the equation. Okay, that equation is TR is equal to pi minus theta divided by omega d. TR is equal to pi minus theta equal to omega d, where theta equal to what, my dear? Cos inverse of theta, correct? Because cos theta equal to what? Theta. We already learned that, right? And pi is equal to 3 point what for you know? Omega d is equal to omega root of 1 minus theta square natural. I mean damped oscillation frequency. And this rise time can be defined in 3 ways, my dear. It is very, very important you listen it, because in one textbook you may find rise time as 10 to 90%. In some it may obtain a 5 to 95. In some you may see simply 0 to 100. And it is clearly, I will tell you what it is. See, TR will be time taken for the response, time taken by the response to attain, or response to increase from 10 to 90% for underdamped case. Okay, for underdamped case, my dear. And again it will be confusion, na? It is always confusing. For overdamped case. And it is the time taken by this response to increase from 0 to 100% for underdamped case. And it is the time taken by the response to increase from 5 to 95% for critically damped. This you have to always remember. I am very confused. I am also very much confused. Sometimes I got forgot, because this is that much confusing now. So 10 to 90 overdamped, and underdamped means 0 to 100. 0 to 100 for underdamped, and critically damped means 5 to 95%. So this is the exact definition of a rise time. So sometimes you may simply, some other will say 5 to 95. For what system it is 5 to 95? It is critically damped system. And sometimes it may be 0 to 100%. The time taken by the response to increase from 0 to 100, that means simply nothing but, my dears, up to this, that's simply up to here to here. What is the time? That is called the rise time. Okay, so in this figure, generally you can say that it will be the rise time. This will be the rise time. Generally, 0 to 100 you can take for this underdamped system. This is for underdamped system. Because we are giving this equation for underdamped, 1 minus theta square, because this is for underdamped, because theta less than 1 for underdamped, so that this equation will be valid. So that system is valid for underdamped system. That's why this equation is valid for the 0 to 100 you can take. If they are specifically saying for critically damped means you have to take for 5 to 90, that will be the definition. And overdamped means 10 to 100. Okay. Okay, my dear. Is it clear? So you remember in any way. Okay, you remember in some, you can apply some trick and all. You can remember. Over means 10 to 100. 10 to 90 over. 10 to 90 over. Under means 0. Critically means okay. In between over and under, you can remember that critically. Because critically damped means theta equal to what? 1, correct? Na? So theta greater than 1 means overdamped, theta less than 1 will be underdamped. Na? So you can remember it that way. 10 to 90, array, havan korchu over aanu parayilla Malayalamil. So 10 to 90. So it will be over. And നമ്മുടെ എക്സാമിനൊക്കെ അണ്ടറായി എന്ന് പറയില്ലേ, നമുക്ക് അണ്ടറായി എന്ന് പറയുമ്പോൾ നമ്മൾ ഒട്ടും കയറിയില്ല. എനിക്ക് 0 ആണ്, ഞാൻ അണ്ടറാണ്. 0 to 100 will be under. So 100 under, 100 under, you can remember in that way. 100 under. So end is there na, so 100 under, so 0 to 100 will be under damped, and over means 10 to 90 is over, and critically, suppose in hospital means the pulse level or the BP level and all, critical value means there should be some value na 5 to 95, or you can remember in that way. It's your choice. Okay, it's your choice. Is it clear? Means rise time, do you clear about rise time? Okay. And third one is peak time, TP. It is the time taken by the response to attain maximum value for first time. What is the meaning of that? This isn't, my dear. For first time means for first sinusoidal wave. This is for second time. This third. This is for second time. This is for third time. This is for fourth time. This is for fifth, etc., etc. This is called overshoots or undershoots. Overshoot means over portion. Undershoot means this portion. Overshoot means this portion. Undershoot means this portion. This is called first overshoot. This is called first undershoot. This is called second overshoot. This is called second undershoot. This is called third overshoot, and this is called third undershoot, my dear. Overshoot and undershoot. Okay, so for first time means this is called the peak time, TP. You can write here. This is called a TP. This is called TP. Correct? For obtaining the maximum value, for obtaining maximum value for the first time. So this will be the 1. Ideally it should be 1. For first time it will be more than 1 na? So that is why it is obtained. We introduced a signal in between. The system, what happened, the suddenly system respond to and produce a very high output there, and later on the system will itself adjust its value, and the system will be slowly attain stability. That is why, because there is capacitor and inductor, my dear. That is the main reason for the stability. Capacitor and inductor is there, na? That is the main reason for stability. Okay, it is the time taken by the response to attain maximum value for the first time, and there is an equation for peak time, my dear. TP is equal to n pi divided by omega d, and n will be equal to 1 for first overshoot, and equal to 2 for first undershoot, and equal to 3 for second overshoot, and equal to 4 for second undershoot. So the value of n will be, there is a trick to find the value of n, my dear. That trick will be tell you, trick. For overshoot, simply you have to multiply it with 2 and minus 1. For undershoot, simply 2 only. Okay, listen. For first overshoot means you have to take n as overshoot is multiplied with 2 minus 1. So for first overshoot, 2 into 1 minus 1. It is simply 1. For undershoot na, it is simply you multiply it with 2. So for first undershoot means 2 into 1. For second overshoot, 2 into 2 minus 1. For second overshoot, into 2 minus 1. So 2 into second overshoot means second means 2. 2 into 2, 2 into 2, 4 minus 1, 3. And for second undershoot, it will be into 2 only. So it will be 4. Someone ask you 16th undershoot, how will you say? 16 into 2, n is equal to what? 16 into 2. 74th overshoot, n will be equal to what? 74 into 2 minus 1. That's all. That is how you can take the value of overshoot and undershoot, my dear. overshoot and undershoot. So there is the equation for n pi by omega d. All know this. This is the equation for peak time. That is the equation for peak time. Is that clear? Is that clear, my dears? Okay? You got this? You got this? Fourth one. So delay time, rise time, peak time. Next one, settling time. TS. The equation for settling, what is the meaning of settling time means? It is a time taken by the response to settle to a final value, settle to a final value with some tolerance, which means this is the at the time of step signal you applied, the system will be respond like this. Slowly the system itself can adjust upon that instability, and at a maximum after very long duration of time, in the sense not hours or not a day, the capacity of the system will depend upon that. After 2 seconds or after 3 seconds or after 5 seconds, even after 10 minutes, it will attain stability. But that system always have some tolerance level, means some error. That is the meaning of final value with some tolerance. This tolerance level, this is called tolerance. Percentage tolerance, that is the correct word, my dear. Percentage tolerance. So with some percentage tolerance, it will settle down after some time. So the settling time equation TS will be equal to, my dear, equal to 3 tau, 4 tau and 5 tau for 5% tolerance, 2% tolerance, and for 1%. So this is very important relation, my dear. This is very important relation, and tau will be equal to, my dear, tau will be 1 by zeta omega n. Tau will be simply RC, but in the case of RLC circuit, it's not RC na, it will contain some another function. So it is simply 1 by zeta omega n. Okay, you remember in that way, tau is equal to 1 by zeta omega n. Okay, so that is the equation for settling time. So by doing problem, these terms will be more and more clear. Okay, it will be more and more clear to you. Is it clear, my dears? Is it clear? So that is the meaning of settling time. Next, overshoot or undershoot. Overshoot or undershoot. There is an equation for overshoot or undershoot. E raised to minus zeta n pi divided by root of 1 minus zeta square. This division is for this exponential. No, the upper term, okay, not for the whole. Remember that, okay? E raised to minus n zeta n pi divided by 1 minus zeta square. What is the meaning of overshoot, my dear? Overshoot means this is the overshoot. This is the first overshoot, then first moving up, and this is the first undershoot. This is second overshoot, and this is second undershoot. Okay, so this value now, my dear, this value it is called a maximum peak overshoot. This is called a maximum peak overshoot. So maximum peak overshoot will be equal to what? E raised to minus theta pi divided by root of 1 minus theta square, because that means for n is equal to 1. That means maximum peak overshoot means at a first overshoot, my dear. At a first overshoot is the maximum peak overshoot. Maximum peak overshoot. Did you heard that word, maximum peak overshoot? You blindly heard that word before. So now it is clear, right? So this is the first time at the first overshoot, maximum value is called the maximum peak overshoot. Correct? Is it clear, my dears? And the value of n will be similar. N will be 1 for first overshoot and 2 for first undershoot. Correct, na? You can remember in that funny manner. Okay, in funny manner. In police, suppose a robber is running very fast, and the policeman he is also chasing the robber, but he should shoot the robber on an under portion. Under means there is 2 legs, right? Under portion. So under these 2 legs only he can shoot. So under means into 2. Correct. Simple. Under means 2. In that manner I remember. Your choice. It is your choice. You can remember in any way. Okay. So I am remembering that one. Under means okay, you are under arrest. Shoot. Tum tum. In below that legs it can shoot. That's why the name undershoot. Clear? Over will be into 2 minus 1. That will be always in your mind. Okay. Clear, my dears? Okay. That's all for overshoot and undershoot. Peak overshoot. That first peak overshoot. Correct? First peak overshoot. Is it clear, my dears? Is it clear? Next, it's a problem actually, but through that problem you have to learn a lot, my dear, a lot. So learn this problem. Suppose in a question, my dear, the pole location of in an S-plane, the pole location in a S-plane, so it is nothing but sigma, and this is nothing but j omega d-axis. Sigma plus j omega d-axis, okay. So, or simply j omega axis, you can use that way on j omega axis. So, this is the pole location or the pole orientation in a system, in a S-plane. So from this you have to learn a lot. This is nothing but the rest opposite mirror image of the poles. So you have to learn a lot from this, my dear. From this you have to conclude a lot. That conclusion I will tell you one by one. So conclusions. From this single figure, you have to conclude a lot. First one. Can you tell me about the theta now? So this is theta 1, this is theta 2, this is theta 3. Correct? The first one will cover the theta 1, okay, and this will be theta 2, this will be theta 3. Am I correct, my dear? So I can say that theta 1 greater than theta 2 greater than theta 3. Correct, no? Theta is nothing but cos inverse theta. Theta is nothing but, my dear, cos inverse theta. So I can conclude one more thing. Theta 1 less than theta 2 less than theta 3. Am I correct? Because cos theta is nothing but theta. If theta or theta increases, its cosine value will be what? Bigger. Or cos inverse theta is equal to theta. Correct, na, my dear? If theta is goes on increasing, means this is the maximum value of theta. That will be the minimum value of theta, because cos inverse theta is theta. Cosine value will be high for lesser value of angle. Correct? So theta 1 less than theta 2 less than theta 3. That conclusion you can make. And another third conclusion you can make. Overshoot or undershoot will be that is not okay. Simply okay. Next one, omega d1 equal to omega d2 equal to omega d3. Omega d1 equal to omega d2 equal to omega d3. That means the damped oscillation for first pole will be equal to the damped oscillation of the second pole will be damped of the third pole. How can it obtain? Because it is straight line now. This all lies in this here. Only it's a sigma 1, sigma 2, sigma 3 are changing. The sigma are changing in respect to one each pole. This is for sigma 1, this is for sigma 2, and this is for sigma 3. That is minus eta omega n, that is only here. But omega d, this is actually what, my dears? Minus eta omega n plus or minus what? Omega d. Correct, na? Minus eta omega n plus or minus omega d, na? This omega d is the imaginary factor, j omega d, correct? Plus j omega d for underdamped system, minus, correct? So it will be, this one is the omega d. The omega d will be same, this pole will be omega d same. So you can write like omega d1 equal to omega d2 equal to omega d3. Okay? Is it clear, my dear? And from fourth conclusion is that, TP1 equal to TP2 equal to TP3. Because TP is equal to what? N pi divided by omega d. If omega d is constant, my dear, its peak time also constant, na? Peak time also constant, correct? Peak time also constant. Because peak time n pi divided by omega d. If omega d is constant, means for first pole, second pole, third pole, everything, the peak time will be constant. And fifth conclusion, TR1 less than TR2 less than TR3. Because in rise time, my dear, there is an equation for rise time. What is the equation for rise time? Because TR will be equal to pi minus theta divided by omega d. Pi minus theta divided by omega d. Correct? If theta is increasing, we learned that theta 1 is maximum, theta 2 is less than, and theta is the minimum, which means TR1 will be for max. When theta increases, what happen? The numerator decreases, na? When theta increases here, pi minus theta, na? So theta increases means the numerator decreases. Numerator decreases means TR1 TR decreases, na? So increasing theta means decreasing TR. So this is increasing value. So opposite will be the decreasing, na? So TR1 less than TR2 less than TR. So that's all. And sixth conclusion, my dear, tau 1 greater than tau 2 greater than tau 3. How that happens? Tau 1 greater than tau 2 greater than tau 3. How that happens, my dear? Tau. Tau is nothing but the time constant, time constant. Tau is nothing but time constant. Time constant, how it will be increasing? How it will be increasing? How it will increase? You have any idea? The time constant will be increasing. Zeta omega n. Yes, can say like that. I will tell you. Because we have, my dear, tau and zeta omega n is connected in way that tau is equal to 1 by zeta omega n. Am I right? Tau is equal to 1 by zeta omega n. Tau 1 is greater than tau 2. That means if zeta increases, tau will be what? Decreases. Correct? Now, zeta increases, tau will be decreasing. Zeta decreases, tau will be increasing. See zeta 1. Zeta 1 is the least value. Zeta 1 is the least value. So tau 1 will be the maximum value. That's all simple. That's all simple. See, my dear, this conclusion you have to revise it many times. It will tell you a lot about your knowledge. This conclusion this is very, very important. No need to solve 50 or 60 problems. You learn this concept and you remember it and you revise it, because you have to play a lot with the equations. Then only you will. It is only a one line, but you have to think a lot for getting that one line. This is only for one line, but you have to think a lot. That is why this problem is that much important. Okay. And the sixth conclusion, 7. Along with that, you can write one more thing, my dear. Ts will be equal to what? Ts will be equal to what? 1 by zeta omega n. No. Ts will be, tau will be 1 by zeta omega n. And Ts will be what? Ts will be 3 tau, 4 tau and 5 tau. Generally, Ts will be proportional to tau. Ts will be proportional to tau. So, if tau increases here in this manner, I can say that the settling time also increasing the same manner, my dear. The settling time also increasing the same manner. See, think how your thinking level is. You can check. You have to play. You have to play with the equations, my dear. And the next conclusion you obtain, my dear. And see, what is omega d now? It is not conclusion, you can learn along with. Omega d is nothing but omega n root of 1 minus zeta square. Okay. We have this omega d is a constant here. Omega d is a constant. That means this is a constant. For making this is a constant means if omega n is decreasing, the zeta has to, for make this constant, if omega n is decreasing, the whole factor should increase. This is decreasing means the whole factor, the root factor should increase. The root factor should increase only when? The root factor should increase only when zeta also decreases. Correct? Zeta also decreases. Which means if omega d is a constant, both omega n and zeta increase or what? Sorry, Mary. Sorry. For omega d to be a constant, this is a constant, my dear. This is a constant. Okay, this is a constant. For make this as a constant, suppose omega n is decreasing. This 1 minus zeta whole, this root of 1 minus zeta square should increase. Correct? If this is increasing and this is decreasing simultaneously means this always omega d will be a constant. If the whole thing will be increasing means, what is the meaning, my dear? What is the meaning? The zeta should be decreasing now. That means for make for making omega d a constant, both omega n and theta decrease or increase simultaneously. If this is increasing, suppose this is increasing, means this whole term should be decreased now. The whole term decrease means this also increase, theta also increase. So both omega and theta simultaneously increase or decrease only will make omega d a constant. Omega d a constant. Is it clear, my dear? Is it clear? Okay. And that is the up to that sixth conclusion. And next conclusion. We have tau is equal to 1 by theta omega n. Am I correct, my dear? Zeta 1, zeta 2, zeta 3 all are what? Theta 1 less than theta 2 less than theta 3 na. So I can write like omega n equal to 1 by theta into tau. Am I correct? If theta is theta 1 less than theta 2 less than theta 3 means theta 1 is the least value na. Theta 1 is the least value. So omega n will be the highest value. So I can write like omega n1 greater than omega n2 greater than omega n3. Correct? Theta 1 will be the least value, so omega n1 will be the highest. Correct na? Correct now, my dear? Tau 1 is higher na? Tau 1 is higher. Okay, listen, my dear. Tau 1 is higher. Okay, listen, my dear. Okay. Here, say one thing. Here, tau is increasing means zeta decreasing na. Zeta decreasing means the omega n also decreasing. Then only this whole will be decreasing. Correct na? Tau increasing and 1 by zeta omega n. This zeta omega n whole factor should be decreasing. Then only tau will be increasing. For that, zeta should be decreased already. We learned. At the same time, omega n also to be decreased, right? Because suppose zeta alone is decreasing and omega n is goes on high means this tau will not make any sense. So this omega n also decreasing, correct na? This omega n also decreasing. So it will be correct na? 1 minus theta square, correct. But everything is correct. So this term will be omega n should be what? Decreasing, goes on by decreasing. So maximum tau omega n goes on increase, so tau will be increasing. So maximum tau 1 is greater than, my dear, listen. This tau is increasing the maximum for T1 na. Maximum for T1 means at that time omega n will be least na. Omega n will be least, correct. Now it is clear. Did you get that? See, tau 1 is higher maximum value compared to all three. Tau 1 is higher. Tau 1 is higher means at that higher level omega n1 will be less na. Suppose this is tau 1 and this is omega n1, this will be the relation, correct? So tau 1 is higher means omega n will be lesser, so omega n will be the least value. See the level of question. Yes. It is not easily understandable. It's very high level question. It's very, very high level question. Okay, is it clear? So you got a conclusion, right? You got very much conclusions. That's all about the question, my dear. Next question also a conclusion type. Suppose the orientation of pole is like that. Suppose the orientation of pole is like that. Suppose the orientation of pole is like that. This is 1, 2 and 3, 4, the third pole. This is 1 dash. And this is G omega axis. Then what are the conclusions, my dear? So I will give you conclusions. First one. Of course, there is no change in theta, right? Theta is a single line now, all poles. So I can write like theta 1 equal to theta 2 equal to theta 3. Correct? That is the first conclusion. And also, if theta 1, theta 2 all same, then what will be zeta 1? Zeta 1 also same now, because cos inverse theta, cos theta is theta now. So zeta 1 equal to zeta 2 equal to zeta 3. So third conclusion. For this, maximum peak overshoot to 1 will be greater than, no, everything will be same. Will be equal to maximum peak overshoot to 2 equal to 3. For n is equal to 1. Because for n is equal, figure what is the equation for peak overshoot, my dear? Maximum peak overshoot will be e raised to minus n is equal to 1 now for maximum, for e raised to, so peak overshoot will be what? Overshoot or undershoot equation, e raised to minus zeta pi divided by root of 1 minus zeta square. Zeta is a constant. So everything will be constant. Peak overshoot for first pole, second pole, third pole, everything will be constant. Array, my dears, see, what is the peak overshoot? Overshoot or undershoot equation. E raised to minus zeta n pi divided by root of 1 minus zeta square na. Correct? So this n is equal to 1 for first overshoot or undershoot, that will be the maximum peak overshoot, correct? So maximum value will be n is equal to 1, correct na? So first overshoot or undershoot will be equal to e raised to minus zeta pi divided by root of 1 minus zeta square. It's overshoot, not undershoot na. First overshoot will be n is equal to 1, undershoot will be n is equal to 2. So e raised to minus zeta pi divided by 1 minus zeta square. Zeta is a constant, my dear. Zeta 1 is equal to zeta 0 plus zeta 3. So maximum peak overshoot for the pole 1, pole 2, pole 3, everything will be what? Same. That's all. See how, what are the way you have to think. Next, omega d3 greater than omega d1 greater than omega d2, right? d2 greater than omega d1. That is a damping frequency, my dear. Damping frequency, how it will be? How it will be greater and greater? How it will be greater and greater, my dear? Yeah, simple. Omega d3 is nothing for this one. This is omega d1, because j omega axis now, my dear. J omega axis. Omega d is nothing but the j omega term. Sigma plus j omega d. We have what? Sigma plus j omega, or that is j omega d na. So this is for omega d1. This is for omega d2. And this will be for omega d3. So omega d1 less than omega d2 less than omega d3. That's all. So omega d3 will be the maximum na. This will be the maximum na. Omega d2 below that, omega d1 below that. Simple. Think and write. Think and write. Okay. Next conclusion. TP3 less than TP2 less than TP1, TP3 less than TP2 less than TP1. How? Because the peak time will be equal to what? N pi divided by omega d, correct na? If omega d is increasing manner, it will go on decreasing manner, because Tp is equal to this much. If this is it goes on increasing manner, means this goes on decreasing manner inversely. That's all. Next conclusion. Sixth conclusion is that correct now, because TR have a relation TR is equal to delay time, rise time, pi minus theta divided by omega d. Na? If omega d is in increasing manner, means TR will be decreasing manner. This opposite to this one will happen there. Huh? Seventh one. Tau 3 less than tau 2 less than tau 1. Why? Again we have the equation, my dear. How can we assume that equation? We see tau is nothing but 1 by zeta omega n, correct now? Zeta 1, zeta 2, zeta 3, everything will be same, and omega n will be how can I attain omega n? Zeta will be a constant, so omega n will be what? Yeah, that's all simple. So 1 by zeta omega n, my dear. So listen, this value of pole having certain omega n1, correct na? This value of pole having certain omega n2, and this value of pole having certain omega n3. That's all, my dear. So I can say that zeta is a constant now, we won't bother about this. Omega n is goes on what? Omega n is goes on increasing now. In left side it is goes on increasing now. So omega n3 will be maximum. Omega n3 will be in magnitude wise, my dear. In magnitude, it's all are, these all will be related to the what magnitude only you can take. Omega n1, omega n2, omega n3 na? Minus zeta omega n minus zeta. This all contain minus. You neglect minus. Simply you take zeta. I mean omega n only. So omega n will be, you can write like omega n3 greater than omega n2 greater than omega n, because it goes on increasing, my dear. It goes on increasing now, omega n. Correct? So what will be T? Opposite will be T. Ts3 less than T. T3 less than T2 less than tau 1. Correct? And settling time. Ts will be equal to what, my dear? Ts will be equal to, or Ts will be directly proportional to tau na. So tau is in this manner, it is increasing in Ts3 less than Ts2 less than Ts1. That's also in the same manner, because it's proportional quantity. And next conclusion. Yes, correct. That's also simple. That's all. You learn this, at least you should take 1 hour to learn this. Two graph, now this 2 graph, you should take at least one hour to learn. That much you have to think, then only you will get the answer. Is it clear, my dear? Is it clear? If you have any doubt, please mention in the comment section, or you can directly contact to my number, my dear, because if you take more time to learn means you can contact me, I will explain. Okay? If you feel any shy in the comment section to comment your doubt and all, you can directly call me, or you can directly text me or WhatsApp me to my number. Okay? There is in the description box, my number is there, you can directly call. It's okay? So that's all for today. I hope you learned a lot today. Okay, revise it, learn it, and please come tomorrow only after learning this. Then only there will be a continuity, my dears. Okay? Otherwise it will be lost. Right? So thank you so much. So take care. That's all for today. So let's meet again tomorrow. Bye.